Okay, so the absolute function, absolute value function, we've talked about that before. We did a graph of it. It's one of our toolkit's functions. We know it looks like a V. And we know we can transform that. We can shift it and flip it and stretch it and compress it. Okay. The absolute value function is going to look like f of x equals the absolute value of x. But we talked about this function when we talked about piecewise functions. And we said it really comes in two pieces. If the number is greater than or equal to 0, then you just have x for the output. If x is greater than or equal to 0. So if you take the absolute value of 7, you get 7. Okay. But if it's less than 0, then you do the opposite of x. And so if you give us a -7, then we take the absolute value. It's the opposite of -7, which is 7. Okay? So this is the formal definition of absolute value. In the past, we probably just explained what it was. Okay, so this next part talks about, and you can read it, but I'm just going to summarize it, electrical parts, and they have a resistance, like resistors measure a certain resistance, and because of manufacturing, sometimes these parts that they're making, electrical parts, they're not all exactly the same. Sometimes they're just a little bit different, but they're considered the same value, okay? But each piece might vary a little bit. So it says the best that manufacturers can do is try and guarantee that the variations stay within a specified range, often 1%, 5%, or 10%. Okay, so it says here, suppose we have a resistor rated at 680 ohms, plus or minus 5%. Use the absolute value function to express the range of possible values of the actual resistance. So what I'm going to do is I'm going to kind of work this backwards. I'm going to do kind of with the more practical approach. So it's saying we have a resistor that's supposed to rate at 680 ohms, but we're going to accept it if it's up to 5% off above or 5% off below. So what I really need to know is what's 5% of 680. So I grab my calculator, I go 0.05 times 680, and I get 34. So I need the ohms to be either 34 higher, within 34 higher. So what's 680 plus 34? 714. Or it could be lower. So it's 680 minus 34. 646. So I need my resistance, I'll use R for resistor, to be greater than or equal to 646 or less than or equal to 714. That's the range. So if you come to me with a resistor that's 800 ohms, that's going to be too big. But if you come to me with a resistor that's 700 ohms, that's going to be okay. It'll be in the range. Or if you came to me with one that was 650, that would be in the range. Okay. So how do we do this? Well, we want to use the absolute value function here. All right. So what was my example? If you came to me with one that was 800, and I subtract the 680, what is that, 120? See, that's more than that 34. 34 was as many ohms as it could be off. And this is off 120, so that doesn't work. All right. And the other one I said was what, 650? I said 700, but let's use 650. If I subtract 680 from that, I get negative 30. But see, the absolute value of negative 30 is 30, and so I'm within that 34 mark. Like, that's okay, it's less than 34. So this is okay. All right, so how do I express this idea? Well, I'm trying to take the absolute value of the resistor that you give me, minus 680, and I want that to be equal to 34. And then that tells me the range of possible values, okay? This is the equation then. And we're going to leave it right. This, like, it would give you the 714, because you'd take 680 and add 34, and it gives you the 646, because you're going to take 680 and subtract 34. Now we're going to learn how to solve these equations in just a couple of videos.